Ever wonder why a cup of hot coffee becomes cold after a while? It's a simple observation, isn't it? But it's one that's steeped in complex science. Similarly, have you ever thought about why ice melts when left at room temperature? These are not just random changes but are governed by a scientific principle called thermodynamics. Intriguing, isn't it? Well, the answers lie in understanding two key concepts in thermodynamics: state function and path function. So, what exactly is a state function? Well, let's break it down. Imagine you're on a hike and you reach the top of a hill. Now, whether you took the steep rocky path or the gentle winding trail, your altitude at the top is the same. This is a simple example of a state function. It's a property of a system that depends only on its current state, not on how it got there. Think of it like this. You've got a cup of hot coffee sitting on the table. The temperature of that coffee doesn't care if you heated it up in the microwave or on the stove. It doesn't matter how you got there, only what the final state is. That's what makes it a state function. Now, let's dive a bit deeper. In thermodynamics, properties like internal energy, enthalpy, and entropy are all state functions. They depend solely on the initial and final states of a system, regardless of the path taken to get there. For instance, the amount of heat absorbed or work done during a reaction might vary based on the path, but the change in internal energy will remain the same. So it's not about the journey, rather the destination that matters. In the realm of thermodynamics, the path is irrelevant when it comes to state functions. So remember, a state function is all about the final and initial state, not the journey. Now, let's shift gears and talk about path functions. Imagine you're going on a road trip. The total distance you travel and the amount of fuel you use will depend on the route you take. If you take the highway, you might cover more distance but use less fuel because of the smooth roads. On the other hand, if you take a shortcut through a hilly region, you might cover less distance but end up using more fuel due to the difficult terrain. This is the essence of what we call path functions in thermodynamics. Path functions, as the name suggests, are dependent on the path taken to reach the final state. They are not just about the beginning and the end, but about everything in between. Unlike state functions, which are like a snapshot of a system at a particular state, path functions are like a movie, capturing the entire journey from the initial to the final state. Path functions include properties such as work done, heat transferred, or the distance traveled. These values can change based on the route taken. For example, the work done on a system can be different if we compress a gas quickly or slowly, even though the initial and final states are the same. So remember, while state functions capture what the system is like at a specific state, path functions tell us how we got there. So unlike state functions, path functions are all about the journey, not just the destination. So let's quickly revisit what we've learned today. We've dived deep into the world of thermodynamics, dissecting both state functions and path functions. State functions, we learned, only care about the beginning and the end, like the altitude of a mountain peak. Path functions, on the other hand, are all about the journey, like the distance traveled on a road trip. These concepts aren't just textbook theories, they're part of our everyday life. Remember, whether it's a cup of coffee cooling down or a car ride, thermodynamics plays a vital role. So keep exploring and stay curious.